So we get 8,623. So hopefully you got that one right. Now, the hardest part of the Chinese system are the three features that actually distinguish it from one that is purely multiplicative grouping. We've been doing the first one. The unit symbol is represented by a single symbol rather than two symbols. We just write the multiplier, but we don't write the 1. The power of 10 is omitted there. Okay, in the pair involving the tens, if the multiplier is a 1, the multiplier is omitted. So you just write the symbol 10. So if you had 310, for example, you would write 3, our favorite little detonator dude, okay, 300, and then you actually write a 10. And actually, if your 0 occurs at the bottom of the number, at the end of the number, you just omit the symbols. And that's what number 3 covers. When a given power of the base is missing, the omission is shown by replacing the multiplier and base with a single 0 symbol. Furthermore, if several powers of the base in the row are missing, this is indicated by a single 0 symbol. Well, that's good, as complicated as that is to draw. Should the 1s or the 1s and 10s be missing, no 0 symbol is needed. So that's what I was talking about in this case. Okay, so let's do one together. 3,008. So 3,000. Okay, 3,000. We have no hundreds or tens, so we need that nasty old 0 symbol. Okay, and kind of that funny looking P. Okay, so that would be the 0. Notice we only need the 1 0 to cover the hundreds and the tens. And then we need the symbol for 8. So this is saying that, this is saying that, and this is saying that. So it is a little bit tricky. All right, now see if, let's take a look at the next one, 4,200. We want 4, which is our curtains or our face, however you want to think of it. 4,000. Okay, 4,000. 200. Okay, our little detonator. No 10s and no 1s. Notice because the zeros occur at the bottom, we don't have to put those in here. We can stop at this point. So that's one of the ways it deviates from a purely multiplicative grouping. Okay, now I have two numbers for you to try to write, 9,073 and 5,210. See if you can write those. You can pause the recording and try to write those, and then when you think you have your answers, restart it and you can check yourself. Okay, I'm hoping that you have tried the two numbers now. All right, so we need 9,000, so that's our fancy H. 9,000. We have 0 hundreds, so when we have 0 hundreds, we have to put that nasty symbol for 0 in here. Okay, and that weird looking P that's kind of laying to its side. All right, so there's our 0. Then we need 70, so, and a 10, and then 3. So 9,000, there's the 0 hundreds, and then 73. Okay, 5,210, that's our rocking chair. Okay, is the 5. 1,200. It's a little bit bigger. Our detonator. 10, we just need the symbol for the 10. We don't need the multiplier. And because the 0 for the 1s occurs at the end, we don't have to put the 0 in. So thank goodness for that. Okay, so that is the multiplicative grouping as shown by the Chinese system. Now, one of the things they also introduce us to in this particular section is what is known as the Egyptian algorithm for multiplication. And if we want to multiply two numbers, 21 times 45, what we do is we start with a 1 and one of the numbers. So I chose to start with the 1 and the 45. And then I keep doubling the number until 21 is exceeded in the left-hand column. So I'm kind of looking for my 21 here. So I know if I double it again, I'll get a 32, which I don't need to do that. Now, what we do is we want to pick numbers in the left-hand column that add up to 21. And start with the biggest number, so I'm going to start with 16. 16 plus 8 would be too large. That would give us 24. 16 plus 4 would give us 20, so that's going to work. And 16 plus 4 plus 2 would be too big, but plus 1 would be correct. So that tells us that we want to pick the numbers from the other column and add them up. So we're going to add 45, 180, and 720. And if we add those up, we end up with 945, which is the correct product. So basically what they're doing is they're doing the multiplication by adding. So you want to try multiplying 34 times 52. So let's start with a 1 and a 52. And go ahead and see if you can multiply using the Egyptian algorithm. If you want, you can pause the recording right now and give it a try, and then start it up again so you can check your work. Okay, I'm assuming you have done this, so I'm going to start doubling the columns. Let's see, double 2, double 104, double 4, 416, double 8, I get 16, and that would be 832. Double 16, I get 32, and 1664. So notice if I double again, I'll have 64, which is larger than my 34. That's what I'm trying to get. So again, I want to add up to get 34. So 32 plus 2, that means I need to add these two, 1664 and 104. 8671. So I got 1768, and you can check that on your calculator or by multiplying out by hand to come up with the result. Okay, so now you're ready to play the recording that shows sample problems.